Harvesting corn silage wasn't just hard work, it required raw power. Before forage harvesters, farmers cut corn with binders, shocked it in fields, hauled whole stalks to silos, then laboriously chopped everything by hand or with stationary cutters. It was backbreaking, time-consuming, and limited how much livestock a farm could support. Then came mechanical forage harvesters, implements and self-propelled machines that could chop entire corn plants in the field, blow them into wagons, and finish acres per hour instead of acres per day. Today we're counting down the 10 most powerful vintage forage harvesters ever built, machines that revolutionized dairy and beef operations by making high-quality silage practical on commercial scale. Let's discover the choppers that dominated silage season. Starting our countdown at number 10 is the John Deere 34 forage harvester, the pull-type implement that brought reliable chopping to small and mid-sized dairy operations. Introduced in the 1950s, the 34 represented Deere's entry into serious forage harvesting. While smaller than later models, this pull-type harvester featured the engineering quality that made it a workhorse on thousands of farms. The 34 used a flywheel chopper design with knife-mounted blades arranged around a heavy flywheel. As corn entered the throat, the spinning flywheel's knives sliced through stalks, creating chop lengths adjustable from 1/4 to 1 inch, depending on knife spacing and shear bar adjustment. Power came from the tractor's PTO, typically requiring 40 to 60 horsepower for continuous operation. The Deere's clutch system allowed engagement and disengagement without stopping the tractor, essential when clearing plugs or making adjustments. A 2-row corn head attached to the front, gathering stalks and feeding them into the chopper throat. The head used gathering chains and stripper plates to pull corn plants from the ground while leaving roots behind. Adjustable deck plates controlled feeding speed, preventing overloading that would stall the machine. Chopped material shot through a spout that pivoted and adjusted to direct silage into trailing wagons. The spout featured a deflector hood that operators could adjust to compensate for wind or change trajectory. The 34 excelled in smaller fields where maneuverability mattered. Its relatively compact size meant tighter turns and easier transport between farms, important for custom operators serving multiple dairies. For thousands of small dairy farmers in the 50s and 60s, the Green 34 represented affordable entry into mechanical silage harvesting. Gehl claims number 9 with the CB400 forage harvester, the Wisconsin-built implement that specialized in fine chopping for high-quality silage. Gehl Company from West Bend, Wisconsin, focused exclusively on forage harvesting and hay equipment, bringing specialized engineering that larger full-line manufacturers couldn't match. The CB400, introduced in the early 1960s, represented this focused expertise. The distinctive feature was Gehl's uni-shear cutting system. Unlike conventional flywheel choppers that use multiple small knives, the CB400 featured fewer but larger blades with a continuous shear bar. This design produced cleaner cuts with less power requirement, important for farmers with smaller tractors. The cutting chamber design minimized metal-to-crop contact, reducing heat buildup that could decrease nutrient quality. Gehl Engineering understood that silage quality depended on consistent particle size and minimal processing damage, so every component focused on gentle, precise chopping. The CB400 offered exceptional adjustability for chop length. Farmers could quickly change theoretical length of cut from 3/8 inch to over 1 inch by repositioning knives or adjusting feed rolls. This versatility meant one machine handled both fine-chopped haylage and coarser corn silage. A unique feature was the spring-loaded rock trap in the gathering head. When rocks or foreign objects entered, the trap door dropped, allowing them to fall through rather than entering the chopper. This simple system prevented expensive knife damage, common with competing harvesters. The CB400's blower produced exceptional throw distance, up to 70 feet under ideal conditions. This meant wagons could trail at safer distances without losing material. Gehl's orange harvesters became common across Wisconsin's dairy country, representing specialized engineering, meeting specialized needs. International Harvester enters at number 8 with the 350 forage harvester. the red implement that brought IH's heavy-duty engineering to silage operations. Introduced in the mid-1960s, the 350 represented IH's commitment to the growing forage harvest market. As dairy operations expanded, demand grew for harvesters that could handle high-capacity chopping without constant breakdowns. The 350 featured a massive flywheel weighing over 200 pounds. This rotating mass maintained momentum through heavy feeding, reducing power spikes that stalled lighter machines. When encountering thick corn or heavy feeding, the flywheel's inertia carried through momentary overloads. IH designed the 350 with commercial operators in mind. Heavy-duty bearings throughout the drive system, chain drive size beyond minimum requirements, and reinforced frame construction meant this harvester survived punishment that destroyed lighter implements. The knife mounting system used individual blade holders that could be replaced without dismantling the entire flywheel. This meant damaged knives, common when rocks or metal entered the chopper, could be changed in minutes rather than hours. Custom operators appreciated this design when downtime meant lost contracts. The hydraulic spout control allowed operators to adjust throw direction without leaving the tractor seat. This convenience improved safety and efficiency, especially when filling multiple wagons in succession. The gathering head options included 2-row and 3-row corn heads, plus hay pickup attachments. This versatility meant one harvester handled multiple crops throughout the season: corn silage in fall, haylage in summer, and even small grain silage in spring. The IH Red 350 became the choice of professional custom harvesters who needed reliability under extreme conditions. New Holland commands number 7 with the 770 forage harvester, the blue implement that pioneered metal detection technology in chopping equipment. New Holland, already dominant in hay equipment, entered forage harvesting in the 1950s and quickly established reputation for innovation. The 770, released in the early 1970s, incorporated features competitors rushed to copy. The most significant innovation was the optional metal detection system. Magnets and sensors mounted in the feeding path detected ferrous metal before it reached knives. When metal was detected, an alarm sounded and feeding stopped automatically. This system prevented knife damage that could cost hundreds in repairs and hours in downtime. The 770 featured New Holland's exclusive floating cutter head that automatically adjusted to crop flow. When heavy slugs of corn entered, the cutter head floated slightly, maintaining knife-to-shear bar clearance without operator intervention. This prevented jams common in fixed head designs. The blower design used straight rather than curved paddles. New Holland engineering determined straight paddles moved material more efficiently with less power consumption. The result was lower fuel usage and cooler operating temperatures. Chop quality on the 770 was exceptional due to precision knife mounting, each blade seated in a machined pocket with minimal tolerance, ensuring uniform cutting height. Proper knife sharpening and adjustment produced silage particle sizes within a few 30 seconds of an inch variance, critical for optimal fermentation and feed digestibility. The gathering head design incorporated crop dividers that could handle badly lodged corn that tangled other harvesters. These dividers lifted fallen stalks while separating adjacent rows. New Holland's Blue 770 became the benchmark other manufacturers studied when designing their own harvesters. John Deere returns at number 6 with the 3800 forage harvester, the self-propelled machine that ended Deere's pull-type era. By the early 1970s, dairy and beef operations had grown beyond what pull-type harvesters could handle efficiently. Self-propelled machines offered dedicated power, improved operator visibility, and capacity that pull-types couldn't match. The 3800 featured a 6-cylinder diesel engine producing 120 horsepower, power dedicated entirely to chopping rather than shared between propulsion and harvesting like pull-types. This meant consistent performance regardless of terrain or crop conditions. The operator station, positioned high above the gathering head, provided visibility impossible with tractor-pulled units. Operators saw corn rows ahead, monitored feeding, watched for obstacles, and adjusted direction, all while observing material flowing into trailing wagons. Hydrostatic drive controlled ground speed independent of engine speed. Operators maintained optimal engine, RPM for chopping while adjusting forward speed to match crop conditions. Light corn meant faster ground speeds. Heavy, thick corn required slower travel. The hydrostatic system made these adjustments infinitely variable and instantaneous. The cutting mechanism featured knife-over-shear bar design with 12 knives around the flywheel. Theoretical length of cut adjusted from 1/4 inch to 3/4 inch through gear changes affecting feed roll speed relative to knife rotation. The 3800's gathering head options included 3-row corn heads and platform heads up to 14 feet wide for windrows. Quick attach couplers allowed head changes in under 30 minutes. Self-propelled reliability and capacity made the 3800 popular with large dairy operations and custom harvesters covering hundreds of acres per season. Hesston claims number 5 with the 7700 forage harvester, the revolutionary machine that pioneered rotary knife cutting systems. Hesston Corporation from Kansas approached forage harvesting differently than competitors. Rather than refining conventional flywheel designs, Hesston Engineering developed the rotary knife head, a system that changed industry thinking about chopping. The 7700, introduced in the mid-1970s, used a rotating knife drum rather than a flywheel. Multiple knives mounted around this drum cut against a fixed shear bar, but the rotational speed and cutting geometry differed fundamentally from flywheels. The rotary design produced several advantages. First, cutting action was gentler, less shattering of kernels and stalks, preserving more natural sugars for fermentation. Second, power consumption decreased by 15 to 20% compared to equivalent capacity flywheel choppers. Third, throughput capacity increased because the continuous rotation maintained steadier crop flow. Chop length adjustment on the 7700 was revolutionary. Rather than changing gears or repositioning components, operators simply adjusted feed roll speed with a hydraulic control. This infinite adjustability meant precise control of particle size to match specific feeding programs. The 7700 featured Hesston's exclusive center pivot steering. Unlike conventional steering where front wheels turned, the entire machine articulated in the middle. This provided incredibly tight turning radius, essential in small fields and when maneuvering near buildings. The cab design was industry-leading, with air conditioning, stereo, and ergonomic controls that reduced operator fatigue during long harvest days. Hesston recognized that comfortable operators worked more efficiently and safely. The white and red Hesston 7700 forced competitors to reconsider their engineering assumptions about forage harvesting. Case IH commands number 4 with the 8820 forage harvester, the high-capacity machine that dominated custom harvesting operations. Following the merger of Case and International Harvester in the 1980s, the combined company developed the 8820 specifically for operators needing maximum capacity and reliability. This wasn't a machine for small farms. It was engineered for professionals chopping thousands of acres per season. The 8820 featured a turbocharged diesel producing over 300 horsepower. This massive power allowed chopping speeds that left competitors behind. While other harvesters traveled 3 to 4 miles per hour through corn, the Case IH maintained 5 to 6 mph without overloading. The cutting system used 16 knives around a 40-inch diameter flywheel, the largest in the industry at that time. This combination delivered throughput capacity exceeding 100 tons per hour under optimal conditions. Large dairy operations and feedlots requiring massive silage inventories found the 8820 indispensable. Kernel processing became standard on the 8820 through a specialized roller attachment behind the cutter head. These counter-rotating rollers cracked corn kernels without over-processing the rest of the plant. Research proved kernel processing improved starch digestibility by cattle, increasing milk production and feed efficiency. The operator cab rivaled agricultural combines for comfort and technology. Automatic header height control, ground speed control linked to crop flow sensors, and diagnostic systems that monitored all major functions represented the most advanced forage harvester technology of the 1980s. The gathering heads for the 8820 included 6-row corn heads and 16-foot platform heads. These wide heads matched the machine's capacity, allowing efficient coverage of large fields. The red 8820 became the standard by which other high-capacity harvesters were measured. Fox Harvester storms into number 3 with the Super 3000, the Wisconsin-built machine that European engineering brought to American farms. Fox, a small Wisconsin company, licensed technology from European manufacturers who had developed forage harvesting to extreme levels. The Super 3000, introduced in the 1980s, represented this transatlantic engineering collaboration. The most distinctive feature was the knife drum design. Rather than a flywheel with peripheral knives, the Super 3000 used a cylindrical drum with spiral-arranged knives. This geometry provided smoother feeding, reduced power consumption, and produced exceptionally uniform chop length. The knife mounting system allowed individual blade adjustment to within 1/1000th of an inch. This precision meant every knife cut exactly the same, producing silage with particle size uniformity competitors couldn't match. Dairy nutritionists noticed the difference. Fox chopped silage fermented more consistently and showed improved digestibility. The Super 3000 pioneered the use of replaceable wear plates throughout the cutting chamber. Rather than replacing expensive castings when wear occurred, operators simply bolted in new wear plates. This reduced maintenance costs dramatically. The blower design produced throw distances exceeding 100 feet, crucial when filling tall bunker silos or large piles. The combination of high-speed blower and properly designed spout meant silage landed where intended with minimal power wastage. Cornhead design on the Fox incorporated independent row units that floated separately. This meant each row could follow ground contours independently, gathering every plant without scalping on high spots or leaving stubble in low-value areas. The bright orange Fox Super 3000 became the choice of farmers and custom operators who refused to compromise on silage quality. Claas claims number 2 with the Jaguar 800, the German-engineered machine that redefined forage harvester sophistication. Claas, dominant in European agriculture, entered the American market in the 1990s with the Jaguar series. The 800 represented engineering developed over decades in European conditions where efficiency, precision, and reliability mattered more than raw size. The cutting system used V-shaped knife arrangement around a heavy drum. This geometry pulled material into the cutting zone more aggressively than flat knives, maintaining capacity even when crop moisture varied. The V-angle also provided self-cleaning action that prevented buildup common in other designs. Claas pioneered electronic monitoring of all critical functions. Sensors continuously measured knife sharpness, feed roll load, engine parameters, and throughput. The system alerted operators to problems before failures occurred and automatically adjusted feed speed to prevent overloading. The kernel processor on the Jaguar 800 featured adjustable gap control from the cab. Operators could match processing intensity to crop moisture and maturity without stopping. Crucial because optimal processing changed throughout harvest as corn dried. The cab design and controls reflected European ergonomic standards. Every function was logically positioned. Climate control maintained perfect comfort, and visibility exceeded anything built in America. Operators accustomed to conventional harvesters needed adjustment time to Claas sophistication. Maintenance access was exceptional. Large panels opened to reveal all serviceable components. Daily maintenance that required 30 minutes on competing harvesters took 15 on the Jaguar. The green and white Claas Jaguar 800 showed American farmers what world-class forage harvester engineering looked like. Taking the #1 position is the New Holland FX60, the ultimate evolution of mechanical forage harvesting before precision agriculture transformed everything. Released in the late 1990s, the FX60 represented the pinnacle of conventional forage harvester design. Every lesson learned over 50 years of mechanical chopping was incorporated into this 600 horsepower monster. The power came from a 16-liter diesel engine producing output that seemed excessive until you watched the FX60 work. Through 8-row corn at 6 miles per hour, it never slowed. Never hesitated, never struggled. The capacity exceeded 150 tons per hour, more than most dairy operations could handle with wagon logistics. The cutting system featured 24 knives around a massive 48-inch diameter drum. The drum rotated at 900 RPM, creating knife-tip speeds exceeding 120 miles per hour. At these speeds, cutting was instantaneous and uniform. The kernel processor used specially designed rollers with differential speeds. The upper roller turned slower than the lower, creating a crushing rather than squeezing action. This processed kernels without over-processing the fiber portion that provided effective fiber for cattle. Electronic controls managed everything. Engine load sensors adjusted feed speed automatically, maintaining optimal throughput without operator input. Sharpness monitors detected dull knives before poor cutting affected silage quality. GPS integration tracked field location, yield mapping each load for analysis. The 8-row corn head featured automatic row sensing that steered the harvester perfectly down rows even at high speeds. Operators essentially supervised rather than drove. Maintenance intervals extended dramatically through better materials and engineering. Oil changes every 500 hours, bearing inspections every 1,000 hours, far beyond what earlier harvesters achieved. The FX60 wasn't just the best forage harvester, it was the machine that proved mechanical harvesting had reached perfection before electronics began dominating agriculture. This was agricultural engineering at its absolute peak. Raw power, mechanical precision, and reliability combined into one ultimate silage machine. From the reliable John Deere 34 that brought mechanical chopping to small dairies, through the innovative Hesston 7700 with its revolutionary rotary knife system, to the ultimate New Holland FX60 with its 600 horsepower and electronic sophistication, these 10 forage harvesters represent the evolution of silage harvesting technology. They transformed dairy and beef operations by making high-quality silage practical on commercial scale. Modern harvesters add GPS and precision agriculture, but they build on foundations these mechanical marvels established. Collectors treasure surviving examples, recognizing them as the machines that powered the dairy industry's growth and fed millions of cattle. What's your favorite vintage forage harvester? Share your memories in the comments below and subscribe for more agricultural history, because these silage chopping machines deserve to be remembered.